Hello, this is Module 2 of our Tertiary Elementary Programming Principles, and to kick it off is Levels of Programming Languages. In our previous module, Module 1, we defined programming languages as the process of designing a set of instructions that can be used to perform a specific task by use of a computer. There are many programming languages. The languages are classified into two major categories. The categories are low-level programming languages and high-level programming languages. Each programming language has its own grammatical or syntax rules, which must be obeyed in order to write valid programs, just as natural language has its own rules for forming sentences. Let's discuss these categories of programming languages, starting with low-level programming languages. Low-level programming languages are the basic programming languages, which can easily be understood by the computer directly, or which require little effort to be translated into computer understandable form. Low-level programming languages include machine languages and assembly languages. Which are the features of low-level programming languages? They include 1. That they are machine hardware oriented. That is, the programmer needs to have the hardware to be used with this software in mind. Like if it is a certain type of CPU, he has to program this program in such a way that this CPU will be able to run alongside the software or the program created. They are not portable. That is, a program written for one computer cannot be installed and used on another computer of a different family. The other feature is that they usually use mnemonic codes. And to write a program statement in assembly language or in low-level languages, the programmer uses a set of symbolic operation codes called mnemonic codes. This code could be 2 or 3 shortened letter words that will cause the computer to perform a specific operation. For example, if one wants a program to add 2 or more values, he will use ADD for addition. If he or she wants something to be moved from one point to another, he will use MOV for move. If one wants to subtract 2 or more numbers, he will use SUB for subtraction. And if one wants something to be read, he will use RD for read. Those are just examples of mnemonic codes that are used in low-level programming languages, especially in assembly languages. Another feature is that they frequently use symbolic addresses. Machine languages are also called first-generation languages, and they are usually written using machine codes or binary digits that consist of zeros and ones. A programmer is required to write his program in strings of zeros and ones, and calculate and allocate the core memory locations for his data and all instructions. The computer can readily understand machine code without any translation. Different CPUs have different machine codes. Let me give an example. Codes written for the Intel Pentium processors may differ from those written for Motorola or Silic's processors. Therefore, before interpreting the meaning of a particular code, a programmer must know for which CPU the program was written. Remember, we said that low-level languages are hardware or machine hardware oriented. A machine code instruction is made up of two main parts. Part 1, an address or operand. An address or an operand specifies the location or the address of the computer memory where the data to be worked upon can be found. Part 2. A function or operation code. This part usually states to the control unit of the CPU what operation should be performed on the data or item held in the addresses, e.g. addition, subtraction, division, multiplication, etc. Note that the computer can only execute instructions which are written in machine language. This is because it is the only language which the computer can understand. Therefore, any program written in any other programming language must first be translated into machine language or binary digits before the computer can understand it. Let's move on to the other category of low-level languages, which is assembly language or second generation languages. Assembly languages were developed in order to speed up programming, that is, to overcome the difficulties of understanding and using machine languages. The vocabulary of assembly languages is close to that of machine language, and the instructions are symbolic representations of the machine language instructions. Assembly language programs are easier to understand and use and also modify as compared to the machine languages. You also find that assembly language programs have less error chances. To write program statement in assembly language, the programmer uses a set of symbolic operation codes called mnemonics, as I had mentioned, and the code could be 2 or 3 shorted letter words that will cause the computer to perform a specific operation. So we have said that assembly languages were developed in order to speed up programming, because you find that in machine language, or programmers were using zeros and ones, and that's usually very difficult when you want to come up with a certain program that will be performing a specific task and you're writing it in zeros and ones. That becomes very difficult, whereby you find that in our normal language we usually use alphabets. So now using zeros and ones to write something becomes a bit tricky. So that's the reason as to why assembly languages were developed, so that now a person can be able to use normal language, that is English, which will be like representing these zeros and ones. But that again now will require that your computer has what we call language translators that will translate that foreign language that you have used into machine language. And the vocabulary used for these languages, the assembly languages, as I have mentioned, is close to that of machine language. So it's not far from that. So it's just made in such a way that it will be easier for the programmer to write. And usually find that the instructions are symbolic representations of the machine language instructions. So they're just what you'll be writing are just symbols, or you'll be writing in symbols that will be representing the machine language instructions. So instead of writing in the machine language itself, you'll be using some symbols that represent that, and that's in a way will speed up the programming process. What are the advantages of low-level languages? One is that the CPU can easily understand machine language without translation. So you find that with high-level languages, any program statement written must be translated into machine language, and this will take its own portion of time. But with low-level languages, it requires no or less translation, and this will make the CPU to easily understand your program statements, and hence execution will be very fast. The program instructions can be executed by the hardware or processor much faster. This is because complex instructions are already broken down into smaller, simpler ones. So that is self-explanatory. Low-level languages have a closer control over the hardware and are highly efficient and allow direct control of each operation. So you said that with the low-level languages, they'll have closer control over the hardware because, as we have mentioned, these languages are usually machine hardware oriented. So they will be controlling what the hardware is doing. They will be like be able to manage or use efficiently the computer resources. So for that reason, again, you find that the execution of instructions will be very fast, and hence you will become very productive. They are therefore suitable for writing operating system software and game programs, which require fast and efficient use of the CPU. So if you are admiring to write game programs or operating systems, then you have to make yourself familiar with the low-level languages, which are mostly used to write this type of programs. You also find that they require less memory space. So when you're writing these programs, you usually find that they have to be you have to allocate some memory space, and they usually don't take a lot of memory space, and this will save you on your memory. Low-level languages are also stable. That is, they do not crash once written. So, and that's why you find that they are used to write operating systems, softwares, which are the core software, or which is the core software in a computer system. And you will not want to have an operating system that is always crashing. And for that reason, you find that low-level languages are the ones that are used to write such vital programs that when they crash, they may cause, mayhem. They may cause everything not to work. What are the disadvantages? You find that everything that has an advantage will have at least, one disadvantage. So the disadvantages of low-level languages is that very few computer programs are actually written in machine or assembly language because of the following reasons. One is that low-level languages are difficult to learn, understand, and write programs in them. So as I mentioned earlier, low-level languages will be using zeros and ones or symbolics of such digits. So for that reason, you find that it will become very difficult for one to understand, given that a person is speaking in a different language from this. Low-level language programs are difficult to debug, so remove errors from them. So you can now imagine something that is written in zeros and ones, and you are told to find a certain problem, which we call debug or removing errors. So it becomes very difficult for one to be able to identify any specific error in a program, given that the program is written in a different language. Another disadvantage is that they have a collection of very detailed and complex instructions that control the internal circuiting of the computer. Therefore, it requires one to understand how the computer codes internally. So you find that you, as the programmer, you have to beforehand understand how the computer works before you start programming any program with these low-level languages. Another disadvantage is that relating the program and the problem structures is difficult, and therefore it becomes cumbersome to work with. So relating the program and the problem structures is difficult, and therefore it becomes cumbersome to work with. The programs are also very long, and hence writing a program in low-level language is usually tedious and time-consuming. So remember, you are writing in machine language, which will be using zeros and ones, and usually find that when you're using these zeros and ones, for you to represent a specific character, you have to at least have 7 to 8 digits to represent a specific character. So if you are to represent, or if you are to write a word that has, say, 3 letters, you'll need to have at least 8 times 3 or 7 times 3 zeros. So if you're now to write a program that will be into sentences and paragraphs and all that, then you find that you'll be having lots of zeros and ones, and that becomes very tedious, and it will also be time consuming. The programs are difficult to develop, maintain, and are also prone to errors. That is, it requires highly trained experts to develop and maintain these programs. So you'll have to learn and learn and learn and learn and learn again how to develop programs in these languages, because they usually require a lot of skills to develop. They usually requires a lot of skills to maintain, and they are also prone to errors. And we have said that it is difficult for one to identify an error in a program written in low-level language. Low-level languages are machine-dependent, that is, machine-specific, hence they are non-portable. So another disadvantage, as we said when we were discussing the features of low-level languages, is that they are not portable. That is, a certain program written for a certain machine may not be used in a different machine. So for that reason, you find that if you buy a new computer, it may not be having the hardware that the program that you want to learn in it was developed. This therefore implies that they are designed for a specific machine and specific processor, and therefore cannot be transferred between machines with different hardware or software specifications. It is not easy to revise the program, because this will mean rewriting the program again. This is another drawback, that if you are to collect something, if you want to maybe revise something in a program, you cannot just remove or add something on the program. You have to write the whole program again, and that's a very huge drawback there for the low-level languages. Now, those are low-level languages. Let's now discuss high-level programming languages. They are developed to solve or overcome the problems encountered in low-level programming languages. So having used low-level programming languages for a while, programmers encountered some problems. And for that reason, they came up with high-level programming languages to overcome or solve these shortcomings. The grammar of high-level language is very close to the vocabulary of the natural languages used by human beings. Therefore, they can be read and understood easily even by people who are not experts in programming. Most high-level languages are general purpose and problem-oriented. They allow the programmer to concentrate on the functional details of a program rather than the details of the hardware on which the program will run. So unlike the low-level languages, which are machine hardware oriented, for high-level languages, they are usually, unlike the low-level languages, they are usually general purpose and problem oriented. So this will allow a programmer to concentrate on the functional details of the program rather than the hardware details. We also find that high-level language programs are machine uh, independent, so they are not dependent on the hardware. They are independent. They are machine independent, and this will mean that they do not depend on a particular machine and are able to learn in any family of computers provided the relevant translator software is installed. So again, something now here pops up. With high-level languages, if you have any program written in such language, you'll then require a language translator. So this language translator must be installed in the computer that the program will run before you even install it. This is to ensure that the language will be translated into machine language, the language that the computer will understand. Programs written in high-level language cannot be obeyed by the computer hardware directly, and therefore the source codes must be translated into the corresponding machine language equivalent, and the translation process is carried out by a high-level language software translator such as a compiler or an interpreter. What are the features of high-level programming languages? One feature is that they contain statements that are extensive or use extensive vocabulary of words, symbols, sentences, and mathematical expressions, which are very similar to the normal English language. So we have mentioned that high-level programming languages were developed to overcome or solve the problems encountered in low-level languages. And one of the problems was that you are writing in a foreign language. So to overcome that, high-level programming languages were developed in such a way that we can use a vocabulary that is close to the normal English language which we usually use, and that usually overcomes that problem. Purpose of high-level languages, and these are the purpose of high-level languages. One, to improve the productivity of a programmer. This is because the source programs of high-level languages are shorter than the source programs of low-level languages, since one statement translates into several machine code instructions. Another purpose is to ease the training of new programmers, since there is no need to learn the detailed layout of a procession or sequence. To speed up testing and error collection. So we understood that in low-level languages it was a bit hard to test and collect errors. So high-level languages were developed, or one purpose of the high-level language was to make easy the testing and correction of errors. Another purpose is to make programs easy to understand and follow. So this was another drawback of low-level languages, that it was a bit hard to understand and also to develop. So the purpose of developing high-level languages was to make programmers to understand and follow their program statements. Advantages of high-level languages includes one, they are easily portable. This to mean they can be transferred between computers of different families and learn with little or no modification. So unlike low-level languages, which are non-portable, high-level languages are portable, and this is to mean that they can be used on any computer family. All you need is to have a translator in that computer. You need to have a language translator in that program. Another advantage is that high-level language programs are short and take shorter time to be translated. So because they are using a vocabulary that is close to English, then they become very short in such a way that you can be able to explain yourself in a few words. They are easy to learn, understand, and use. So, because they are using a vocabulary that we are already familiar with, it becomes easy for a programmer to learn and understand, and also to use the specific program. Collecting errors and maintaining programs written in high-level languages is very easy. Yeah, for the simple reason that they are using a vocabulary that is close to the one that we are used to. Another advantage is that it is easy to modify and also to incorporate additional features that enhancing its functional capabilities. So unlike the low-level languages that when you want to revise the program, you have to rewrite the whole program again. These ones, they are developed in such a way that you can be able to easily modify and incorporate features that you may want in future. They are also user-friendly and problem-oriented, hence can be used to solve problems arising from the real world. So these programs or these language programs are user-friendly and they are also problem-oriented. So like you'll develop them or a programmer will develop them to solve a specific problem. They enable programmers to adapt easily to new hardwares. This because they don't have to worry about the hardware designer of the computer. High-level language programs are self-documenting. That is, the program statement display the transparency of purpose, making the verification of the program easy. What are the disadvantages of using high-level languages? High-level languages are not machine-oriented. Hence, they do not use the CPU and hardware facilities efficiently. So we discussed that one advantage of low-level languages rather is that they will efficiently use the hardware. They will efficiently use the computer resources because they are machine-oriented. High-level languages, on the other hand, are not machine-oriented. Hence, they don't have close control of the hardware, and for that reason they will not be able to use the CPU and the hardware facilities efficiently. The languages are machine independent and cannot be used in programming the hardware directly. So if you are programming some softwares meant for some specific hardwares, you cannot use high-level language. You'll have to use a low-level language, uh, and usually find that programmers who program programs meant for hardwares will use low-level languages so that the program statement are quickly translated because these hardwares will be used more frequently. So they need instructions that are written in machine language and that do not require any translation, uh, so that they can be used, quickly and easily. This, on the other hand, is a disadvantage because, as we saw, to write in low-level language is a bit time-consuming and cumbersome. Each high-level language statement converts into several machine code instructions. This means that they use more storage space and it also takes more time to learn the program. So we said that with low-level languages, they usually take less memory in your computer's memory. With high-level languages, because they have to be converted into their machine code equivalents, and these codes have to be stored in the computer, you usually find that they will take more space. And because they have to be translated into a computer language, it also takes a lot of time. Another disadvantage is that the program's statements are too general. The program statements are too general, hence they execute slowly than the machine code program equivalents. So you find that with the low-level languages, the program statements are specific. But unlike that, high-level language statements, program statements are too general, and for that they take very long to be executed to their machine code equivalents. They have to be interpreted or compiled to machine readable form before the computer can execute them. So unlike low-level languages, program statements which are directly executed, uh, high-level program languages have to be executed or have to be interpreted first or compiled first before they are executed, and this will take some time. Another disadvantage is that the languages cannot be used on very small computers. Yeah, because you find that um, these small computers use some specific hardwares. I usually find that the low-level languages are the ones that are used to uh, develop programs that are used in these small computers. The source program written in high-level language needs a compiler, which is loaded into the main memory of the computer and thus occupies much of memory space. This greatly reduces the memory availability of a source program. That's also another sort of disadvantage of uh, high-level languages, but also something good to note. Types of high-level languages. High-level languages are classified into 5 different groups. The groups includes third-generation languages, also called structured or procedural languages, fourth-generation languages, also called 4GLs, fifth-generation languages, also called 5GLs, object-oriented programming languages, also called OOPs, and web scripting languages. The various types of high-level languages differs in the data structures they handle, the control structures they support, the assignment instructions they use, and the application areas. For example, whether they are used in educational, business, or scientific areas. Let's start with structured languages. A structured or procedural language allows a large program to be broken into smaller subprograms called modules, each module performing a particular task. This technique of program design is referred to as structured programming. Structured programming also makes use of a few simple control structures in problem solving. The very basic control structures includes sequence, selection, iteration, or looping. We'll be discussing all these control structures in details as the lesson advances. Advantages of structured programming languages. One is that it is flexible. Two is that structured programming programs are easier to read because they are written in a vocabulary that is close to English. Programs are easy to modify because a programmer can change the details of a section without affecting the rest of the program. Those are the advantages of structured programming languages. In our next module, Module 3, we will discuss the fourth generation languages. Until then, have a nice day.